Calling all biology teachers. Yes, you! Are you looking for a fun and interactive way to teach the carbon cycle while meeting the new Georgia Standards of Excellence? Well, then look no further than the Carbon Cycle Mystery Game. This game is perfect for a learner-centered and inquiry-driven classroom. Students are challenged to become investigative ecologists and discover the complex processes and mechanisms involved in cycling carbon. As students work their way around the game board, they discover autotrophs, heterotrophs, photosynthesis, and cellular respiration, and how it fits into the larger idea of the carbon cycle. This game works in conjunction with the Aurasma app to give students an augmented reality experience. Even better, it is free to download and use in the App Store. You will receive full access to all game auras with the purchase of a game board. Are you feeling a bit skeptical? It's hard to believe, right? Well, why don't we take a look at students playing the game and hear their feedback. All right, let's see the game in action.
Okay, so...
Hey guys, welcome to the Carbon Cycle Mystery Game. This week in class, we've been discussing the importance of carbon as we are carbon-based organisms. Today, I'm going to ask you to take on the role of an investigative ecologist. You are going to figure out the roles that both autotrophs and heterotrophs play in the cycle of carbon. Now, before we begin, please make sure that you have the Carbon Cycle Mystery Game board as well as your field notes. The rules of the game are as follows. You are going to work your way around the board by taking turns scanning tiles with your Aurasma app. You can just already download it on your smart device or tablet. Okay, so it looks like they're giving you a definition. Let's see if there's anywhere on your field notes where you can record that definition.
By their ability to create organic nutritional substances or food for simple inorganic substances like carbon dioxide, CO2.
Okay guys, so we just learned a little bit about autotrophs, and now it wants you to scan which of the following is an autotroph. What do you guys think?
I think it's flower.
Oh, we said rabbit, we said flower?
I'm going to scan the rabbit first because that's what I think.
Okay.
Not this one. Please try again.
Uh-oh. Try the flower.
That's correct. I get it right.
Cool.
All right, good job. Let's move on to learning about photosynthesis. What do you think? So we'll scan the orange tile.
And if you
Ooh,
want,
it looks like we've got something to write.
it says photosynthesis is the process by which some autotrophs harvest energy from the sun to build large complex sugar molecules, glucose. Then there's the chemical reaction, which is 6CO2 plus 6H2O, and then the reaction, then 6O2, then plus C.
Okay guys, let's see what we can learn about the chloroplast and how it helps our autotrophs. Okay, it looks like it's given you a diagram. So let's see, I think it wants you to draw the diagram.
Yeah. Looks pretty cool.
Uh-oh guys, looks like we hit our first checkpoint.
Which of the following is not an autotroph? A. Plants. B. Animals. C. Cyanobacteria. And D. Algae.
I think it's A.
I think it's D though.
Someone says A, someone says D.
B.
Ooh, B. Why do you think animals? Nice. We got a second question. So photosynthesis makes what? What do you think?
Carbon dioxide. I think it's A.
I do too.
All right, let's see. It should show us the answer. Oh no, looks like we're all gonna have to go back and review. All right guys, it looks like we're gonna look at the process of photosynthesis next.
In order for plants to grow, they need inputs of carbon dioxide, water, and energy. The chemical process by which plants use these resources to manufacture glucose, the building blocks of plants, is called photosynthesis. In the process, oxygen gas is produced as a byproduct. The energy for photosynthesis originates in the sun and arrives at the earth as sunlight. This light has both a wave and a particle nature. The particles, or photons, are the smallest units of light.
Okay guys, it looks like we are on checkpoint number 2.
So, Dave, what's the first question?
What is station photosynthesis?
It sounds like it's describing the Calvin cycle. Yeah.
All right, I think that's a good answer. Let's see what it says. Oh, you got that one right, guys. Let's look at the next question.
The first one looks like light reactions, and I think the ultimate goal is to split water, or H2O.
Ooh, light reactions, and look at that, to split water as well as creating energy. Good job, guys. And okay, guys, let's scan heterotroph. Let's see what that says. There.
So the heterotrophs are defined by their need.
All right, guys, they want you to figure out which one is the heterotroph. So what do you think?
I think it's the tree.
It might be the tree.
It's mushroom.
I saw tree.
Scan it and try. That's correct. Please move on to the next type.
Yay.
Oh. Not this one. Please try again. All right, good job, guys. Let's move on to cellular respiration. Oh, it's another notes one. Let's scan it again. All right. Okay, guys, let's test our skill on the next checkpoint.
I'm gonna say C.
I think it's a fish.
I think it's C.
All right, let's see what it says. Ooh, sea algae, nice.
Oh.
All right, let's see the next question.
I think it's going to most likely be A.
Yeah, me too.
I think it will be D.
Let's see. Nice job, guys. It is A. Okay, guys, let's go ahead and scan the mitochondria to see.
How do you turn that bite of food into a chemical that a cell can recognize and use as energy? The first step is altering the food into its component chemical compounds and then getting those molecules into your cells. That process is called digestion. Once inside your cells, the process of turning that bite of food into useful energy by cellular respiration begins.
All right, guys, looks like we're on checkpoint 4. Which process of cellular respiration splits glucose into 2 pyruvate molecules? What do we think? Okay, guys, let's figure out where all of this fits together.
Important elements on Earth. All living things are made of carbon. Most of the fuels that humans use for energy are primarily made of carbon, including the food we eat. Gases made from carbon, such as carbon dioxide, play causes carbon to be constantly converted among different forms and locations.
All right, guys, we're on checkpoint 5. Why is carbon important?
I think it's because carbon, like, those molecules are in every living thing, basically.
Interesting. Good job, guys. Let's see what it has to say. Carbon is able to make up to 4 bonds with other molecules, and it's found in all 4 macromolecules that make up life. I think that is a correct answer. Good job. Let's move on. All right, checkpoint 6. On your log sheet, describe the relationship between photosynthesis and cellular respiration. Interesting. All right, you guys talk about it. All right, guys, we are almost done. Let's check out checkpoint 7.
On your log sheet, answer the following. Describe the importance of roles that autotrophs and heterotrophs play in the cycling of carbon. Describe the role of mitochondria and chloroplasts in the transformation of energy and maintaining the homeostasis within the cell.
Okay, guys, this is going to be another collaborative one, so let's talk about those things and we'll record it on our log sheet. Okay, guys, we are almost done. Let's go ahead and check out the summary video.
Yay.
Congratulations. If you're seeing this, that means that you have completed the carbon cycle mystery game. Before we wrap up, I'd like to take a second to review. Autotrophs serve as the foundation of life as they create chemical energy from sunlight and other inorganic substances. This chemical energy can then be used by the autotroph or by any organism that eats the autotroph. Autotrophs typically contain specialized organelles called chloroplasts, which use carbon dioxide, water, and energy from the sun to create glucose, sugar, and oxygen. This process collectively is called photosynthesis. Heterotrophs must consume and break down organic material as an energy source. This is accomplished by consuming autotrophs or other heterotrophs. Heterotrophs typically contain specialized organelles called mitochondria, which break down glucose in the presence of oxygen and create water, carbon dioxide, and cellular energy in a collection of chemical reactions that we refer to as cellular respiration. All right, guys, you are the first ones to ever try out the carbon cycle mystery game. So let's take a second and get some feedback from you guys. Did you enjoy playing the game?
Yes, I did. I thought it was interesting.
All right. Do you like learning this way, using technology?
Yes, I think it was pretty cool.
Okay, awesome. All right, and what do you think about using augmented reality in the classroom?
I like it because it has like a new twist on it.
Okay, very cool. Well, there you have it, folks, straight from the student's mouth. The Carbon Cycle Mystery Game. Teachers love it, students love it even more. Order yours today. It's only $29.99. With your purchase, you get access to the Carbon Cycle Mystery Game Board and 22 separate functioning auras. You get the Field Notes Student Guide as well as the answer key, and you get a Georgia Standards of Excellence compatible lesson planning guide. Order today.